Problem. What is the energy of radar waves with a frequency of 3.35 times 10 to the 8th hertz? Okay, so what we need to do is we need to figure out an equation for energy. And luckily they tell us. Energy is equal to h, Planck's constant, times the frequency. So now what we can do is plug in some numbers. Okay, so we have Planck's constant, which is a constant, right? 6.626 times 10 to the negative 34 joules times seconds. Okay, and then we have to plug in our frequency. Now, with this hertz and seconds, notice how I have seconds here. Do you think I should put in hertz? No, I should probably put in seconds. And it's going to be inverse seconds because, remember, hertz is going to be the same thing as inverse seconds. So I can just substitute one for the other. Okay, so now I can cancel off my seconds. Okay, multiply through. I should get 2.22 times 10 to the negative 25th. This is how many joules there are in one photon. Okay, so another way I can write this is saying this. 2.22 times 10 to the negative 25th joules per, so divided by, one photon. This and this are the same thing. Now the question is asking in kilojoules per mole. So somehow or another we need to convert our units to kilojoules per mole. So I'm going to use unit conversions. Doesn't matter which one I convert first. Let's say joules. So joules will go on bottom, kilojoules will go up on top. How many joules are in a kilojoule? There are 1,000 joules in 1 kilojoule. This allows me to cancel off my joules. And now I'm left with kilojoules, which is great. That's what I want. So I'm going to leave kilojoules. Now I have to get moles. This one is a little bit more tricky. So I'm going to set up a unit version. So right now I have one photon. I need to get this into moles of photons. Okay, so photons goes up on top. Moles of photons go on bottom. What is this relationship? For every 1 mole of photons, we have Avogadro's number. So photons cancel off, and now we're going to be left with moles. Okay, multiply and divide. You should get 175 kilojoules per mole. Now, if you wanted to, you could also say 175 kilojoule per mole of photons. Either way is fine, but you'll see it more commonly written as this. Here's another problem. CD players use lasers that emit red light at 685 nanometers. 685 nanometers, what is that referring to? Is that the frequency? Is that the wavelength? Is that the energy? This is your wavelength. Now it's asking what is the energy of 1 photon of this light? And then another one is asking what is the energy of 1 mole of photons of red light? So you have to do two parts. One, you find the energy of 1 photon. Second thing, you find the energy of 1 mole of photons. I want you to go ahead and try this problem. Use the previous problem to guide you if you're kind of unsure how to do something.